let's cover on how we parameterize the board to work with interrupt routines. I already created a project, empty project on Atelic, and I have my main function here, and I deleted everything else that I don't need. Before I keep going and explaining what are the next steps, just want to cover really quick that there are websites that explain all this stuff that I'm covering, and I don't discourage you guys to follow these websites. The only downside about this is that they don't tell you where did they get this information from. So yes, it's convenient, you probably have the code, you can copy and paste and have it running, but it's not going to tell you what's going on with each single line of code that you have here. So use it with paying attention how much you can get out of that, and keep watching the videos because I give a little bit more information than what it's available on these websites. So let's go back to our code. And how do we approach these if we don't have websites, if we just have the datasheets? Well, we go to our reference manual, the one that has 1,700 pages. And if we scroll down, eventually we'll see chapter number 12 that talks about interrupts and events. And if I press there, it's going to give you a little bit more information about what's going on with interrupts. That you have 82 maskable interrupt channels, you have 16 priority levels, all this good stuff. And it has something called external interrupt that consists of, it's a controller that consists up to 23 edge detectors for generating interrupt requests. And then each line can also be masked independently. Alright, so this is probably something that we are going to use when we interface with IO pins. If we scroll down a little bit more, we have the table here with a little bit more information about the addresses of these registers. Let's keep going, and eventually I get to the block diagram of your external interrupt block, and this is where the fun starts. Look that we have the input line. This is where your pins are going to be connected to. We have an edge detected circuit that interfaces with a bunch of registers that we have here, and eventually also communicates with the NVIC interrupt controller, and it also generates a pulse over here for your processor. And what else do we get out of these? Let's keep going down. We have here which pins can we use for our external interrupts. We're using the STM32F4. I have the 07. So for me, I'll be interested on using these external interrupt 0 to 15 by using from 0 to 15 bits. And notice that your external interrupt interfaces pins from port A0 to port I0. If I keep scrolling down, now it starts giving more information about the registers. We don't need to worry about that. And then next gives you more information about the ADC and how to use the interrupt routines with the ADC. We don't need to worry about these right now. So let's just focus on these external interrupts for our application. Alright, what's going to be the application that we're going to use to practice these interrupts? We're familiar with the three different types of programming, the pulling, interrupt, and pulling and interrupt together. We're going to do a mix, as you see it over here. We're going to configure the interrupts. We're going to have some stuff done inside of an interrupt routine, and we're going to have some stuff done outside of an interrupt routine, but using software variables to communicate between the service routine and your process. And this is what we're trying to achieve. We're going to have an external interrupt associated with pin 0 of your port A. And whenever that happens, I'm going to blink a red LED. And I'm going to look at GPIO from port A1 And if that happens, I'm going to pay attention to external interrupt 1, use a software variable that communicates with my main and blinks a green LED. So what are the steps that we're going to do? I have the steps summarized more or less here, but I'll show you how do we get to this point that we know what we need to do. We're going to configure the outputs, configure the inputs, then define or configure the external interrupt line to say look at those pins. Then we need to enable the clock for those external lines. We're going to configure the interrupt routines to the NVIC, enable the NVIC, and then we're going to write our own code. Alright, so let's start. We have our main function. The first thing that I'm going to do is to configure the inputs and outputs. I'm going to open my week 1 GPIO. I'm going to reuse some code from this main function. I know that I can use, let's say, I'm going to copy these structures over here and I'll adjust it in a minute if I don't need them. So I define all my LEDs because I need them. I'm going to have 2 buttons, button 0 and button 1. And I have the structure for my GPIO LED and my structure for my buttons. I go to my main and I can copy these init LEDs. Do I need to change anything here? No. I'm going to probably save some memory here and declare these as, only do it this once, as a local variable to my init LEDs. This only happens here. Create, generates, and the green, red, blue, and orange are all enabled. We already went through all this stuff, so we're good. And for my init buttons, I'm going to do exactly the same thing. Copy. And I'm initializing my button 1. If I want both buttons, I will go here and parameterize both right away as button 0 and button 1. Going to pass the structure also. Sorry. Pass the structure inside of this init. And I'm going to close all that. So let me just copy also this to my main function. Here we go. I'm going to close that project. I don't need it anymore. I'm just reusing some code. I'm going to compile and make sure that everything gets deployed properly inside of my board. Compiles fine. I press play and everything works fine. If you want to check if it's affecting your LEDs, you can just again right bit one of those LEDs and it should be good to go. So right now we just configure these two, and let's go over the configuration of the external interrupt line. Alright, so where do we find information about the external configuration? If you go inside of your libraries, STM drivers, and then source, we're going to find access to these external interrupt.c, and that's the one that we're going to open. And now you can see here some features and how to use this driver, and it tells you that you configure the IO input pin with your GPIO init, which I already did, but now we need to select the input source and pick this external line using this system configuration, and then configure that external line and also configure the NVIC after that is done. There is an extra stuff here. Do not forget to enable the system configuration clock, which is this register RCC APB2 peripheral clock. So you enable the clock for the external line. So let's do that so we don't forget. Let's copy this line of code over here. And now I have just a small kind of problem here, because my button 0 and button 1 are going to be done slightly different. So what I'm going to do is I'm going back and just configure everything for my button 0. And I'm going to say that this is initializing button 0. I'm going to fix my main function, initializing button 0. And now after this, I'm going to call this line of code, and I can put a comment here that I am enable clock for my sys config. All right. Then the next step is going to be parameterize your external line. So this external line config. So let's copy, let's find actually where this function is declared. If I right click, open declaration, it gets two inputs. The first one is the GPIO port that I want to use and which pin number do I want to use for this external interrupt. Okay, I'm going to copy this, go to my main, paste it. And now I need to know what to pass over here. It's going to be the port information. So this is part of, I'm inside of this system configuration. So I'm going to leave going inside of my include system configuration.age, and this is the define for my port sources. So I'm going to use this one, go back to my main, paste it there. And the same thing for my pin source, which is going to be pin source 0. Same thing if you go here, going to use the pin source defined over here for my pin. Going to put a comment and tell system that you will use PA0 for, let's say, external interrupt line 0. All right, cool. Let's go back to our steps. So we define all that. Now we are in good shape to parameterize the structure of this external initialization. So right click, open declaration, receives this structure. So let me copy this, and all right, let's declare this structure. Let's go up here, declare the structure. I'm going to call, I don't know the name, let's call external struct external interrupt line 0. Doesn't matter the name. Go here and remember, passes the pointer to that. So commercial and a pointer to my structure. Now all I need to do is to parameterize what it's inside of the structure. We have the line, functional state, the mode, and the trigger. So if you want to know more information about these, we do exactly the same thing that we did for the GPIO structures. We right click on top of the structure, and here you go. We're going to tell which line is going to be line 0. We're going to enable, we're going to specify the trigger, and we're going to say if it's rising edge, falling edge, and enabling line command, which is related with, specifies the new state of this one. So we are going to enable this line command. Same thing happens here. We can hover to get access, rising, falling, mode, interrupt or event driven, functional state if you want to enable or disable. Great, so let's parameterize it. Let's go here, and the first one is our line, and our line is a 0. could use external line 0. All right, let's enable. Let's define the mode. And we want the mode to be interrupt. And then at last, our trigger, we're going to use rising and falling, so both detections up and down. Let's go here and trigger, oh sorry, trigger going to detect up and down. I'm going to compile just to make sure that I don't have any bug on my code. So far so good. I enable the external interrupt, so let's go over the steps again. So we configure the outputs, inputs, we configure the external, we enable the sysconfig clock, and now we need to do step 5 and 6, which is to configure the interrupt routine to the NVIC and then enable the NVIC. Alright, let's go and do that. That's inside of these. If we go back to our system config, the original one that we were dealing with, sorry, the external, if we go up, it's talking about this NVIC, so I do a right click, open declaration to get to know a little bit more about this NVIC, and the NVIC receives exactly the same thing, a structure. So let's do that. Let's copy that code and create this structure going up, and I'm going to create the struct NVIC. Alright, and I pass a pointer to that structure. Now all I need to do is to parameterize that NVIC, so same thing over here. I go to my NVIC, open declaration on the structure, and here you go. I have information about the interrupt routine channel, the preemption, sub priority, and the channel command. So this is the level of my interrupt routine, if I want higher or lower priority. Channel command is going to enable it, and over here I'm going to enable the interrupt service routine. Alright, so how do I get information about what interrupt routine am I going to use? If you go back to your main code over here, you have an assembly file over here, a .s, that if you double click, is going to give you a little bit more information about those interrupt routines, the handlers that you can use. And this is exactly the handler that we want to use. It's going to be this external IO interrupt routine handler. So that means that I need to indicate that I'm going to use the interrupt routine for this handler. Let's go back to my main NVIC, and that information is called interrupt routine, sorry, external interrupt 0. Where do you find this information? If I open declaration, so again, instead of the .h, it tells you that this is the external interrupt line interrupt that you're going to use. You get information for all the other interrupts that you want to use. And from the .s file, the assembler, this is how you're going to call your interrupt routine, service routine from your main code. Alright, let's keep going here and parameterize the rest. The channel command, we are going to enable it, and preemption priority, I want to give highest priority right now, and the last one, sub priority. If I have two with the same priority, what happens? In this case, this is going to have the highest priority, and I pass that NVIC, and let's compile, and we're good to keep going.